Hello everyone. The answer to the question whether thermal energy and heat energy are the same will be cleared. The answer to the question is both yes and no. In what way? The answer is yes. Both the heat and thermal energy are equal in magnitude. In what way? The answer is no. Both the heat and thermal energy are different in their form. How they are equal and different? Before seeing an example, something about internal energy and temperature should be known for better understanding. The term internal energy generally deals with atoms and molecules. It is the sum of all microscopic energies, which include microscopic kinetic energies and other forms of microscopic energies. The various microscopic kinetic energies are translational kinetic energy, rotational kinetic energy, vibrational kinetic energy, and spin energy. Translational kinetic energies due to the movement of atoms and molecules in the space. Rotational kinetic energies due to the rotation of atoms and molecules. Especially the polyatomic molecules exhibit this behavior, and it is also due to the revolution of electrons around the nucleus. Vibrational kinetic energies due to the vibration of atoms and molecules. Spin energies due to the electron spin around its own axis. The other forms of microscopic energies are latent energy, chemical energy, and nuclear energy. Latent energy is associated with the phase change. Externally, energy has to be applied to overcome latent energy for the phase change process. Chemical energy is due to atomic bonds, that is, the energy between electrons of one atom and the electrons of other bonded atoms. Nuclear energy is due to the binding energy between neutron-neutron pair, proton-neutron pair, and proton-proton pair. Generally, temperature is the measure of degree of hotness or coldness of a body. Precisely, it is a thermodynamic property which deals with the intensity of internal energy. If the value of internal energy is high, the temperature will be high. Consider an example. A hot coffee is placed in the atmospheric air. The temperature of the coffee be T1 and the temperature of the coffee is T2. Let the coffee temperature is higher than the air temperature. After some time, we can observe that the coffee temperature will be somewhat lower and the air temperature will be somewhat higher when it is compared with the initial stages. At the initial stage, we can say that the coffee has higher internal energy when it is compared to the second stage. Similarly, we can say that air was at lower internal energy stage when it is compared to the final stage. Now the question is how coffee loses its internal energy and how air gains its internal energy. The answer is some amount of internal energy from coffee is transmitted in the form of heat energy and reaches the air, and it is stored as the internal energy of air. This is the reason for the rise in temperature of air when it is compared to the initial stage. This is known as heat transfer. The process of heat transfer occurs until thermal equilibrium is attained, which means if the temperature of the coffee and air becomes the same, the process of heat transfer comes to an end. Now we can say the transferred form of internal energy is known as heat energy, and the heat energy which is stored as the part of internal energy in the hot body is known as thermal energy. Otherwise, we can say a part of internal energy of the hot body that crosses across the boundary in the form of heat energy due to temperature difference and reaches the cold body is known as thermal energy. Let's see the difference between thermal energy and internal energy. The part of the internal energy that is stored in the hot body is known as thermal energy. The part of the internal energy that is transmitted from the hot body is known as heat energy. So these are the difference between the thermal energy and heat energy. Coming to similarities, the thermal energy which is stored in the hot body is converted into heat energy. So their magnitude are equal, and this is the similarity between them. I hope this video is useful to you. Thanks for watching.